Now let's have a look at something called copy operations. So copy operations are generally used for copying complicated data structures like objects, or let's say arrays. So basically all the uh, it does not make sense to copy like simply primitive data types, right? Primitive data types like I have const x is equal to let's say 5 or 10 or hello anything. So if I create a new variable y and I assign y is equal to x, right? Then obviously this y is also 5. That is fine, but here it does not make sense. This 5 and this 5, they are same, right? Here copying operation does not make sense. Copying operation makes more sense where the data is slightly complicated, non-primitive data type. So let's say this is an array. So when I try to copy, which means that can I create another value, another array which is 1 comma 5, but that is a copy of this 1 comma 5 rather than this the same object, right? So we'll go into that. There are two types of copies which we'll see in this videos. One is called shallow copy, another is one is called deep copy. uh, but before we go into what is a copy, or for that matter shallow copy or deep copy, first of all we have to see what is not a copy. So something like this, let's say we have an object like foo bar, and then we simply do assignment. Let's say obj1 is equal to obj. Then is obj1 a copy of obj? No, actually we don't say that. Why? Because for defining a copy, at least the base addresses should be different as per the definition of copy. Why? Because in this case basically we have simply assigned obj base address, the reference, in obj1. So essentially after this operation what happens is that obj1 is also pointing to the same object and obj is also pointing to the same object. So where is the copy made? The copy is not made, right? In fact both are pointing to the same copy of the object, and that's why this is not a copy, right? And that's why I said that this might be considered a copy in case of primitive types, but we are not considering here primitive types, right? We are trying to consider something like object or array, and we are trying to create a copy of that. Okay, so in this case we'll see that since they are reference data types, if you print something like obj1 and compare it with obj, you will see that it is true. And as per our definition, we will not consider that a copy. For considering it to be a copy, the first and foremost requirement is that their base addresses should be different, which means that essentially they should be different object. Their base address, the location, in the memory where they are located should be different, right? Here it is clearly visible that both are same. Similarly, in case of array, if in case of array we do arr1 is equal to arr or something like that, then again essentially arr1 and arr both are pointing to the same array, and that is again proven by if you simply print arr1 is equal to arr, it will print true, which means that again this is not a copy, right? Now, having understood what is not a copy, let's now understand what is a copy. There are two types of copies. Firstly, we'll see deep copy, and then we'll see shallow copy. Okay, but before that, whatever we did right here just now, when we are saying that it is exactly the same, can we prove that it is exactly the same? Like I just told you that obj1 and obj both are actually pointing to the same memory location. Arr1 and arr both are actually pointing to the exactly same object. Can we prove that? Okay, so in order to prove that, let's take an example, short example. So let's say there is an object. Let's say there is an object, and that object is something like a5, and then there is b, and b is again an object. Let's something like c5, c or 10, that is fine. And let's try to create something which we know that it is not an object as per our definition. But let's see, obj1 is equal to obj, the simple assignment we did. So this is definitely not a copy, just for clarity. Okay, but we have to see the behavior. If something is not copied, simply reference is assigned, then what is the behavior? The behavior is that actually obj1 and obj both are pointing to exactly same memory location. That's why what is going to happen is that if we change obj1 then obj will and we access it by obj, then that will be changed. If we change something from obj side and then print obj1, then that will be changed. Okay, so you can clearly see that, and both are the same, so if we print one, both will be changed. So we'll see that. Let's see obj1 dot a. So right now we can see that obj and obj1 both are the same thing, right? A5 b c10. Okay, now as per the example here, let's change obj1 dot a to 20. Okay, now if I change obj1 dot a to 20, okay, and let's print both. See, actually obj dot a and obj1 dot a both are changed. So basically, even if you just change obj dot a to 20, obj dot a is also changed, because actually internally obj and obj1 are basically pointing to the same memory location. That's why if you change one, another will change. Again, for example, here again you change something via obj, let's say this time. So obj dot b dot c, you change something from here, right? And that was initially dot b dot c, your understanding, right? Go inside obj, or for that matter obj1, both are same only. Inside that, obj dot b will give me this thing, and again dot c will give me this thing, and I'm which is currently 10, I'm reassigning it to 20. And let's print the whole thing again. Okay, so console, some spelling mistake is there. Yeah, so now you see that, yeah, you can see this thing, that now not only obj is changed, obviously I changed obj1 is also changed. Yeah, so clearly you can see that wherever we tamper with one, the another automatically gets changed. So essentially this proves that obj and obj1 internally are at the same memory location. So this is what we discussed right now. Now let's start with something called deep copy. Now, deep copy is a concept where obviously the base addresses will be different. So, for example, when here we printed obj1 is equal to obj, then obviously it will print true. I don't want that. Definitely these two should be different objects. Or for that matter, if we take example of array, we will take later, then they should be different arrays. Base addresses itself should be different. So this should print false, not true. First requirement is that. And then that is a copy, and then on top of that there are two types of copies. One is called deep copy, one thing is called shallow copy. So firstly, let's take a simpler thing, which is deep copy. Deep copy simply means that if you create and definitely this is not the way to create deep copy. The way to create deep copy is something like this. You can do something like json.stringify and then json.parse. What it will do, we earlier learned that json.stringify will create a stringified version of this thing, this object, and then that stringified version will be parsed, which means that it will be again converted back to some native JavaScript object using that string which you provided. Now you can clearly see that I have an object. I have created a complete string, completely different thing, and then from that string I created a new thing. So definitely obj2 and obj don't have anything to do with each other. These two are completely different things, completely different memory locations, right? And that is what deep copy means. Not only the base addresses are different, which is clearly visible from here, that the base addresses are different. Not only that, apart from that, underlying items, whatever underlying items. So here underlying items is foo. In this case, our underlying item is like this 5 and this thing, this object b, right? So all the underlying items, none of them share any references, which means that they don't point to same underlying values. They are completely different. Okay, completely different. So let's try to do that. So let's create some object obj2, and this time we are not simply going to assign, rather we are going to parse. But before parsing we need to stringify. So you understand, from inside we are firstly stringifying, and then the whole stringified thing is passed to parse, and then a new object is created. Now if you print obj1 and obj2, not one, simply obj, then you can clearly see that again both are same, but not only they are same, they don't share any, so they just have the same values. They are completely different thing. So if you print obj2 is equal to obj, then you will see that it is false. But simply printing false does not mean that it is deep copy. It is a copy, that is fine. It is a copy, it is not same object, that is fine. But how to prove that this is deep copy? Which means that they do not share references, right? They do not share references means if you change anything in one, other will not change. If you change anything in other, the first one will not change. Okay, so that is the behavior which you are looking for. So let's see that. So we can clearly see that right now it is something like this. Now let's change something and the same thing can be done with arrays also, right? We will take an example of arrays also by stringifying and parsing it. And again, this is a very simple example, right? If you simply have primitive types, then it is fairly simple. The interesting examples which we will take is that these internal items are not primitive. Again, these internal items are again, let's say, some objects. It is an array of objects or something like that. Then we'll be able to clearly see that those underlying values are they sharing same references or not. What do we mean by sharing same references? If which we are changing, let's say item 1 means this second item, and this is some object, right? If we are changing from one side, let's say arr dot something I changed, then is from arr to I also it is changed, like from arr to, if I print that is changed or not. In this case turns out it is not. In case of deep copy, if we do something like this, then these two are completely different, and even if you temper anything in one, another will not get impacted. We'll see an example soon. So firstly, take an example with respect to objects. So this is the example which we were talking about. Now we created another object, another deep copy sort of, right? And then we saw that they are completely different. In fact, base addresses is also different, and whether internally they are reference wise also different or not. For that, let's prove something like this, that if we change obj1.a, so just for simplicity, take the same name here also, obj1 rather than obj2. So obj is the original object, obj1 is the transformed object, which means that a new object with the same value, the data is same, but actually it is a completely new object. Okay, now let's change something. Let's change obj1.a is equal to let's say 20 or 10. Okay, in this case we are changing 20. Then we will see that if we are printing obj.a, then it is not changed at all, it is still 5. Okay, so what I'm saying is that you can print the whole object also, that is fine. You can see that once I print again, the obj is still 510. You see, so original 510, still it is 510, and the original obj1 was 510, now it became 1010, or let's say we change 20, then it will become 2010. So you understand that whenever we are changing obj1, obj is not getting changed. Okay, these two are completely different. Okay, and in order to and let's change some other thing. So let's say obj.b.c, this time we change, and that we change that to 20. Okay, and then print the same thing, and we'll comment this for right now. So we can clearly see that here again, if I changed obj, then you can see that only obj is changed, obj1 is not changed at all. Again, if I change obj1, then we will see that obj1 is changed, obj is not changed. Okay, so it clearly shows that both obj and obj, whatever values we are tampering with, they are completely independent of each other, right? And in order to prove that whether they share the same references or not, we have already proved this. But apart from that, you can also see that, okay, what if I print obj.b? What if I compare? Earlier we compared the base addresses directly, right? The base address of this whole thing, right? Now obviously this is a primitive type, so they will not have some base address, like obviously they are primitive. We are more interested in we are more so when we are comparing base addresses, there is no point in comparing obj.a and obj1.a, because that is a primitive type, right? So primitive type 5 and 5 both will be 5, so that will not give us much information around what is happening actually. Is the shallow copy happening, or is the deep copy happening, right? So the more interesting thing will be something like this, that if this is an object, so these objects will have some base address, right? Now whether this base address of obj is same as obj1's base address, b's base address or not, right? So that again we can print by something like is obj dot b same as obj1 dot b. You understand? Same as means, are they sharing the same reference? Obj.b, this object's uh, underlying reference, is that same as obj1.b's. And if we print that, then we will see that no, false. And that proves that they are completely different. And that is the whole point of deep copy. Deep copy creates a clone of an original array, or let's say object, anything which is completely different from one another. Okay, now since we have done this, let's take a similar thing, but now in this case let's take the example of an array. Okay, so let's take array. So array, and again we will take some nested examples, so that it is better to see, right? So let's take something like simple, going on the above lines only. Let's take b, and let's take c5 or c10. Okay, so just I'm taking a variation, so that you can take both of them, as objects also. But I'm taking one of the items as primitive type, so one of the items as this object type, so that you can see the difference. Actually right now you will not see the difference, because deep copy is completely different. Okay, so it will not impact. In shallow copy we will see that there is behavior of primitive types different than the behavior of objects, right? Because shallow copy behaves slightly differently. Okay, so but for that matter, right now let's write the same sort of logic, just instead of this we are writing arr, right? And we are taking clone of arr. And now we have a clone of arr. But is this copy a shallow copy or deep copy? That is what we have to prove that, right? Now if we print, or let's say if we change arr arr1 dot let's say a. Dot a means here we will not use, here we will use something like 0, right? arr1 0 is equal to 20. Okay, this thing is changed, and then we print arr also, and then we print arr1 also, and let's see what happens. What was the original value? Firstly we'll print that, and then we'll print. So obviously when we simply created a copy, then this 5 c10 5 c10, like all the values are same, right? Now I'm changing one of the values. We'll see that, you see that, yeah, this thing is changed, and this thing is not changed. You can clearly see, right? And in this case obviously not changed, because I have not touched anything that side. What if I do something like this? Rather than this, I do arr1, right? arr11. What is arr11? arr1 arr1's first item is basically this thing. This thing means it's part of that, and this is like JSON string 5, so it will also have 5 c10, right? arr1 will also have 5 c10. In that I am taking its c, and I'm changing it to, let's say, 20, and then I print arr and arr2. Now you see that only arr1 is changed, right? Original this arr is not changed. And if you do other way around, let's say you do arr1 dot c, arr1 dot c, so the arr you are changing, is arr1 changing? You can clearly see that no, only arr changed, arr1 did not change. So this is the meaning of deep copy, right? Completely different from each other, not sharing any underlying references. Okay. Now let's come to shallow copy. Shallow copy means that they can share some underlying references actually, and the word shallow comes from first level. So what it does is that it takes the first level values, which means that it will take so in this case I will start with this example. What it will do in this case, it will take first level. What are the first level values? The first level values are like A and B. Okay, just it will take those values and it will copy those. It is not going to go deep inside that. Inside B, C is there, and inside C again this thing is, let's say, again some object, and D is there. It does not care about those things, right? It just does shallow behavior. It just goes to one level. Shallow, you understand, right? So if we write it beautifully, then it will be something like this. So only first level. This second level it is not going. So this is like, you can understand, this is second level, right? I don't know, whatever is the first level values A and B, I am just going to those, and then we will simply copy those things. Now here comes the trick. When you are copying the first level things, what is the behavior? How it will be copied? Okay, so first of all, we will see that how to create a shallow copy, and then we will see the behavior. That what is actually happening. So in order to do that, uh, let's take an example of something like this, that first of all, if you do something like spread operator, right? So here we did JSON stringify and JSON parse, right? Now we are not doing that. We are saying that we are creating something like, let's say, const obj3, some other variable, and this thing we are creating something like this, dot dot dot, and then obj. If we use this syntax, then what happens? So instead of this, if we are using this, and then we print the same thing, let's print obj3 and obj. Earlier we saw that in case of simple assignment, that was coming as true. In case of JSON stringify parse, it was false, which means that definitely some copy has been created. What about in this case? I have created a spread operator. I have created a new object using spread operator. Okay, let's see. We'll see that it will again give false. Which means that this is also a copy. Technically, this is also a copy, because we know that if base addresses are different, which means that obj3 and obj is completely are located at different places. But here is the catch. In case of deep copy, everything was completely isolated, like nothing, no references were shared. In case of shallow copy, if there are references at the like second level, like for example here you see that first level is B, this the first level B's values, these are not primitive, these are what, these are objects again, right? These will be shared among obj and among obj3. These will be shared, and that is the meaning of sharing the same references, that is pointing to the same underlying values, which means that actually obj dot b and obj3 dot b internally share the same references, right? Now that is not the case with primitive data types. Okay, primitive data types are copied by value, but these reference data types are copied by reference. You understand? So everything of whatever the values are there for first level, because only first level we are dealing with, right? Only with A and B. So whatever is A, whatever is B, all these will be copied to obj3's A, obj3's B. It will be copied. But the thing is that if the values are primitive, then they are copied by value, and if it is non-primitive, then they are copied by reference. Now what is copy by value and what is copy by reference? Okay, the first thing we have to understand is that when, so let's say this in memory location somewhere obj dot a is there, somewhere it is there, right? Now I am copying it by value. Which means that this obj.3, when it will obj3.a when it will be created, then it is this value just 5. Yeah, 5 is value. I just take that value and I copy it. So that 5 value, a new 5 value is assigned here in obj3 because it is primitive data type, right? So it can be simply copied, right? But in case of references, they don't do that. Why? Because you don't know actually how much complex this might be, 100 levels deep, right? So in order to copy the whole thing, it will take a lot of memory and lot of computation it might take, right? So why to bother about that thing? In case like this is an object, or in case this is an array, let's say 2 3 4 anything, in case this is not a primitive type, then what happens that they don't bother these things. In case they are so we'll see that obj.b, this thing is an object, right? So when we are creating obj dot obj3.b, then we are not copying all the data from obj, rather we are just pointing a reference to the same original object b. Okay, which means that essentially obj3.b and obj.b both are actually internally the same, pointing to the same memory location. Okay, now let's prove that. So so we saw here that they are like this. So yeah, when we print obj and obj3, then obviously they will be looking like same because obviously it is a copy of each other, so technically they will look like same. But here these 5 and these 5 are different, but these c5 and these c5 is same. That is what I'm claiming. Let's prove that. Okay, let's prove that. So in order to prove that, let's do that obj1 dot a I am changing to 20, and then obj not 1, obj3 is there, right? So obj3 dot a I am changing it to 20, and then I am printing obj and I am printing obj3. Let's see what happens. Yeah, you can see that if I changed one, another did not change. And that's why I said that since they are primitive types, we know that yeah, they are lightweight, and we exactly know what is their size and all. So we copy them by value, which means that this 5 and this 5 is different. Okay, is different, which means that technically this 5 is stored somewhere else. This and means here this 5 was stored somewhere else, this 5 was stored somewhere else. You went and changed this 5 to 20, and yeah, that is changed to 20, but it did not impact the other 5. Okay, that is not the case. That is not the case in case of b.c. Why? Because obj3.b.c, firstly see only obj3.b. obj3.b is basically same, the sharing. So obj3.b and obj.b, I am claiming that both are same. In order to prove that, if we write obj.b.c, so we go inside obj3's b and change c, and if obj's b.c, if that got changed, which means that what I'm claiming is correct, right? So that is what we are going to do. So let's print obj3 and obj after that operation. You can clearly see that I changed in obj3, but obj also got changed. And you can do other way around also. You can change obj, and then you will see that still both are changed. Still 2020, right? So either you change obj or you change obj3, both are impacting each other. Like you are tampering one place and effect is happening other place. Why? That is essentially because both are same. And again, you can prove the same thing by seeing that reference. That is it the case that obj.b and obj3.b, is it the case that both are same? And yes, it is true. It is showing that it is true. You can clearly see that when I was doing this thing, spread JSON parse and JSON stringify, right? The answer was coming false. But when I'm doing spread operator, the answer is coming true, which means that JSON stringify, JSON parse did not share anything. Everything was completely independent of each other. But here, some things are shared, some things are not shared. So mainly, if the primitive types are there, they are copied by value, so they will have separate memory locations. But anything which is other than that. So for example, this is, let's say, let's take an example of array also. So instead of this, let's say we have something like this. So let's say b, and that b is let's say 10, 20, whatever. Okay, and right now, obviously when I will print, then 10, 20, 20, 20 both are there, right? What if I change one thing at one place? So rather than so let's say obj, and let's change in 3 only. So obj3 is b, so obj3 dot b. And what do we know? This is now not an object, this is an array. Okay, so I will not do b dot c or something because it does not make sense. But let's say I want to push something. So in that I pushed 30, let's say. And then obviously obj3 dot b should become 10, 20. Obj3 dot b should become 10, 20, 30, right? But will obj dot b change? Will obj dot b, the original object dot b, change? Let's see. Yes, it also changed, right? So you can clearly see that this thing changed, then this also changed. But again, if this would have been a simple something, let's say hello, then this is a primitive thing, right? This is a primitive thing. So if you change obj3 dot b is equal to, let's say, world, then no, but then now it will not impact. They are completely independent. Why? Because you can see that since this is primitive type, they were copied by value, not by reference. Okay, so any object or any array or that type of thing which is object, that will be copied by reference, but primitive types will be copied by value, which means that you can clearly see that 5 was copied, hello was copied, and both are completely different. So if I change obj3.b to world, then yes, only obj3 changed. Obj.b is still hello. That has not changed, right? But again, if this thing is in array and I would have changed obj2 0 is equal to world, then I know that yeah, obj.b, obj3.b, both are same. If I tampered at one place and now it is copied by reference, then you can clearly see that at both places it is changed, right? Okay, so that is the example we took for shallow copy, right? So we took an example, we did spread operator, and we also took another example of this thing of an array. So we took an example array, but the same rule applies here also. So let's assume that the whole thing was an array. Okay, so something like this. Let's remove this all together and let's consider this whole thing was an array. Okay, something like this. Now in this case we are trying to do again shallow copy, and the syntax is that, like here we discussed, right? Here we discussed like spread operator and in curly braces for objects. Similarly, you do spread operator in square brackets of this thing, array. But here it is not interesting, like all the primitive types are there, right? So let's take an interesting example where something is primitive, something is not non-primitive, and we'll see the difference here also, right? So let's take an example of here only. So let's take ARR1, and that thing is now a shallow copy, which is spread operator of ARR. Okay, and then we are going to see that what is going to happen. Okay, so firstly let's print ARR and ARR1. Obviously both are looking like same, but internally what is happening? Internally, let's change ARR1 0 to 20, and let's say what happens to both things. You see that if you change one, another is not changed. Why? Because it was primitive and it got copied by value. But if I change something like this, ARR1.c is equal to 20, then you see that both places it is changed, because internally ARR's first element and ARR1's first element both are same. So you see that ARR1's first element, you set it to 200, then both will be set to 200. or you set ARR to 200, then also it's 200, right? So both are technically internally the same. And here also you can prove that by simply printing ARRs 1 and is this same as ARR 1's 1. Okay, so that is what I'm trying to prove, that the first item in this thing, and the first item is one index, means second item essentially, but the item at index 1 and item at index 1 in both ARR and ARR1, are they same? That is true. Yes, they are same. They are same means they are sharing the same base address. You see the difference. If it is non-primitive type, then even if they are different memory locations, like this is 5 and this is 5, then 0, if you simply take 0 0, right, you see, then also it is true. But it does not mean that they are same. They are different. This 5, the first item of ARR and the first item of ARR1 are at different memory locations. But since they are primitive types, when you equate primitive types, they are compared also by value, right? So that's why it is giving true, right? But that is not the case in reference types. In reference types, if equality is there, which means that their base address is same. If equality is not there, which means that they are different objects and their base address is different and their memory location is different, which is the case that if you do JSON stringify JSON parse and then you test the same thing, then you say that no, it is false. The first item of this and the first item of this are completely different, and that's why it is false. But if you did simply spread operator, then you saw that it is true, which means that they are sharing the reference. And that is a term. When you share the references, some of the references, right, then that type of copy is called shallow copy, because they share the same underlying values. And why shallow? Because it just goes not deep, it just goes one level deep. That's why it is shallow, not multi-level, just one level. One level means that in case of objects, it went to dot a dot b, whatever the first item. In case of arrays, it is just going to like first level items. After that, internally it is b or c, internally it is c, and this is again d. I don't care these things, right? I just copy the first level items, and if those first level items are primitive, I will copy by value. If their first level items are objects, then I will copy it by reference. As simple as that. Okay. So so we basically understood the difference between shallow copy and deep copy. This is important. Now let's see. So we saw spread operator, right? So spread operator, using spread operator, we can create shallow copy. Using spread operator, we can create shallow copy of both arrays as well as objects. There is one more syntax. So if let's say this object is there, right, and I have to create its shallow copy, then I could have done simply spread operator and inside curly braces, and inside that spread operator triple dot obj. That is also one syntax actually, right? That is a newer syntax. There is a slightly this is also ES6 syntax, but this is slightly older syntax and slightly better supported in browsers. That is obj.assign and this thing and this thing. So what happens that obj assign syntax, what it does is that it takes this second argument and assigns it to first argument. Assigns means what? Assigns means inside this it assigns. Okay, so let's take an example. So firstly we will take one simple example. So let's say obj is equal to a5 and b5 or b10, simple. Okay, and then we are going to do something like, let's say, new object obj2 is equal to, now we are going to use this syntax. Okay, obj object dot assign and this thing comma obj, and let's print obj2. Let's print obj2 to see that what it has given us. You see that a5 b10 looks like the same thing, right? Actually what has happened, that it is sort of similar, like you understood, like if it was spread operator, then also it did the same thing, sort of. Actually, the behavior is also same like spread operator. Spread operator also does shallow copy. Object assign also creates shallow copy. So whatever was the behavior of shallow copy, that copied by values, or first level things are copied and copied by value and reference based on whether they are primitive, non-primitive types. That exactly behavior, same behavior holds. It's just that you can do something like this also. So you can understand it that what they are doing is that you can take all the values and then you push it inside this. So let's say it has already had some x1. Let's say it already had x1. Then what happens that inside x1 already was there, and these things were like shoved inside this object. So you can understand it like that. So yeah. Yeah, so just another syntax. So if you and the same thing, if you wanted, you could do here also, right? Like x1 whatever. But this syntax is more used, second one, assign syntax, is more used if you already have an object and want to concatenate, sort of. So in array we sort of saw like concatenate, right? So in a similar manner you can see that this syntax can be analogous to that. Okay, but again, if you check the behavior, this thing will be exactly same again, right? So if you do, let's say here b and here b, c5, whatever the earlier example we took, right? Then here also we'll see that if you do this, then if you change obj to dot b dot c is equal to 50 whatever, right? And then after that you print obj and obj2, then we will see that both will change, right? You see both will change. So same behavior, like whatever was the behavior of spread operator, same behavior, right? Just I'm saying that this is another syntax, obj.assign and empty curly braces and then this thing, right? Again, there is a similar, like as I told you that this is sort of a concatenation. So similarly, if you want to shallow copy an array, then there is a similar syntax. This syntax we already know, that some array dot concat and arr. And this earlier we used it for joining two arrays, right? So let's say 1 2 3 is there, one array, and 3 4 5 is there another array. We want to join them, then we concatenated it, right? But what if we all had an empty array and dot concat and then arr? So basically what happens, that contents of this is copied to empty array, and we created a new array. And that's how a new array is created, which is a copy of the original array. But the point to note is, again, this thing is also a shallow copy, which means that when these were copied, right, when these were copied, then just the references were copied. Okay, it's not that the whole deep copy. If deep copy, you just do JSON stringify JSON parts, right? Otherwise all the things will give you simply shallow copy. So you have to be careful about that, that if you change at one place, another place will change. And another syntax is that you can do array.from arr, right? So yeah, so we have this array, right? And I can create this another array, right? And it can be like array.from. We earlier used this to convert, let's say, iterator, which is not an array, to an array, right? But what if you already have an array and again use array.from? You are creating an array from something which is already an array, right? Why that is can be useful? That can be useful because it will create you a shallow copy, not deep copy, but shallow copy at least it will give you, right? So again, if you print it, then obviously you will get same data wise, it will be same, like, because it is a copy, so it should be visibly same by structure. But technically when you change things, then you will see the details, that when I'm changing the item, first item, then you can see that it is not affecting. But if I am changing the second item, then both are changing, right? So technically the behavior is exactly same as spread operator. So in a spread operator also the behavior was exactly same, right? So again, this is also, instead of spread operator, you can, so now you can see that in case of objects, you can do deep copy JSON string of JSON parts, just period. Shallow copy, objects, spread operator, and then object assign. Shallow copy, arrays, spread operator, array.from, and we saw concat also, and there is one last thing which is called slice also. Okay, so slice is what? Slice gives you a sub array. Slice gives you a sub array. This is what we discussed, right? That if we have some ARR, which is, let's say, 1 2 3 4 whatever, right, then it gives you a slice piece sub array. So ARR dot slice, let's say I take the slice from the second index, what it will give you? 3 4. If I take slice from the first index, then it will give you 2 3 4. If I take slice from the 0th index, 0, and if you don't give the second argument, then it will go all the way till the end. We know that from 0th, then it will give you all the things, and if you don't provide anything, then by default it takes 0 as the starting, and all the way till the end. So again it will give you 1 2 3 4. But my point is this, that what if instead of this my array is something like this, and then I did something like this? What will happen? I have an array, I did slice, and this is some another array ARR2, right? And I created ARR2 using this syntax, const this syntax. What does it do? So actually it creates again a sub array, piece of part of that array, but again it is copied by with respect to shallow copy, right? So basically this will also behave like shallow copy. Okay, so whatever the behavior we got earlier from this, okay, from this, the same behavior we will get if we do, instead of this, if we do this thing. Instead of spread operator, we did slice. Then you can see again the shallow copy, both are changing, right? So so you are getting the fourth way. So again, you always use a spread operator, like it's plain and simple everywhere. But just know that array.from, array.slice, concat, all these things will also give you shallow copies, right? But if you are using it somewhere for other reason, then you should be aware that it creates shallow copy. If you have to create shallow copy, then don't use 5 syntaxes. Just use plain and simple one syntax, spread operator for everything. Whether it is objects shallow copy, whether it is arrays shallow copy, always use spread operator, and that's it. Yeah, so that will be all for copy operations. Let's see with some more content in the next video. That's all for this one.